look, remember, every problem that we're going to do today, you have to try them out. Look, sitting back, memorizing doesn't do you any justice. You have to make sure that you put yourself in the mode to get experience. And to get experience, you have to put yourself right there. Try it out. Real deal. Because look, if you're not practicing, you're not getting ready for game time. You're not working on those little things that you need to work on. So practice, practice, practice. Allow us here to learn from those mistakes so that you don't make them on the actual test. And so today's PSA, before we get started here today, gang, you know I always got to do it. The PSA of the day, perfection isn't the goal on day one. Just start and then improve. All right. And I'm speaking primarily to those folks here that are here for the first time, seriously, because at the end of the day, guys, you know, you're never going to have all of your ducks in a row before you go for that big leap or you go to study for, 4 or 5 hours. Like, it's never all going to be perfect. Life doesn't really work that way. You know, when it does, it's great, but it's not always going to be that way. Sometimes you got to take what you got, try something out, and then improve little by little. That includes your study habits. That includes physical fitness. For those of you guys that are trying to wake up early to work out, like if you're trying to get up at 5 a.m. and you wake up at 5:02 and then you go to the gym, you didn't lose. Like, just improve. Tomorrow, try to get up at 5:01 then, or 5 o'clock, or a little earlier. It's just about making improvements after starting. But if you never start, you can't improve. All right. So I really hope that makes sense. And with that said, if you're about that, man, let's get it. Type in hashtag Ace The ASVAB. Let's go, gang. Let's go. Happy Monday, guys. Oh, I see Ernesto with the first one there this time. Okay. Type it in there. There we go. Let's get it. That is right. That is right. Ace The ASVAB. That's right. Justin tomorrow has his ASVAB tomorrow, man. Good luck. You know, we taught you well here. Just remember, do the little things right. The big thing takes care of itself. Seriously. And also, I found out about that red blinking light from last week. For those of you guys that are still wondering about it, that's just letting you know that you're going over the average time allotted for that question. To my knowledge, it is not going to go ahead and skip the question for you. It's just a light that's indicating like, hey, you're taking a little longer than, the even split for the questions. That's it. So for example, if you got, if it's 10 minutes for 10 problems, so, you have 1 minute for every problem. If it's like 1 minute and 1 second, that's when it starts blinking, basically letting you know, like, you're taking a little longer than normal here. That's all it is. You can keep working on the problem if you know you're close to an answer, or if you know that you have no idea what you're doing, guess and skip. So with that said, everybody, does that make sense? Yes or no? For those of us that are here, asking about that. Perfect.
Yeah.
All right, cool. So with that said, we let a couple people in there and let's go ahead and go. So
and
Mr. Anderson, go ahead and type these notes down, or take these notes down, excuse me.
And Mr. Anderson, I got a question.
Yeah, what's up, Justin? Go ahead.
Are you still doing that practice test?
Yeah. So like I said, I think you were part of that conversation again, where I said we're going to be finishing up that word knowledge bootcamp, which is done now. Paragraph comprehension, that's going to be out soon. Once we got all that going on, boom. We're going to be trying to plan that at least once a month.
All right. Appreciate it, sir.
Yeah, no worries. So everybody, go ahead and take these notes down here. Go ahead and take these notes. So for greatest common factor, notice how I'm not really giving you guys like a formula. Like, I'm giving you the ideas here. We have to learn the ideas at their core. That way, when we do learn a formula, it makes a lot of sense. I'm not going to give you a formula that you guys don't know how to use and then expect you to do well with it. So go ahead, take these notes down. We're going to start with GCF, greatest common factor, okay? Factoring. So numbers that are smaller than that number. But here, greatest common factor is the greatest number that you can divide the two other numbers by. So with that said, like an example, let's go ahead and say we're looking at 12. Let me use a different color here. If we're looking at 12, and let's go ahead and say 18. Well, 12, you can do 6 times 2. 18, you can do 6 times 3. And you can see that they're both divisible by 6. You can also say 12 is, 2 times 6, 18 is 2 times 9. So 2 would also be a factor. But everybody, if we're looking at 2 and 6 and choosing for the greatest common factor, which one is it obviously going to be? The 2 or the 6?
2.
The 6.
6. Right. It's going to have to be the 6 because it is the greatest common factor. All right. It's in the name there. And so sometimes, with math, they do name it in a way that if you continue with it, like it will make sense eventually. And here the naming is not meant to confuse you. It's actually a direct relationship there. Greatest. So the biggest factor that they have in common. It's in the name right there. The greatest factor that they have in common. That's what it is right there. And so if we're checking out again 12 and 18, we can say that, 12, we can say that's 1 times 12, 2 times 6, 3 times 4. 18, 1 times 18, 2 times 9, 3 times 6. And so when you look at that, the greatest common factor, the greatest factor that they have in common is going to be that 6. But notice what else they have in common. They have right here, a 3 in common. They have a 2 in common. They even have a 1 in common. But what matters at the end of the day is the greatest common factor, okay? Greatest as in biggest factor that they have in common, all right? So for at least up to this point, go ahead and give me a yes in the chat box if you got that down. We're going to be practicing in a moment. Don't worry. We're going to be practicing. Give me a yes in that chat box once you have that down and it makes sense to you that greatest common factor is the biggest factor that they have in common. Cool. If you guys think I'm keeping it simple, I'm not. I'm just trying to teach this in a way that's actually like pretty understandable. And so up next, what we're going to be looking at now, guys, is going to be least common multiple. So it's in the name. Least, so the smallest number or multiple that they have in common. So again, guys, it's in the name. Least multiple that they have in common. So for example, if we're looking at this example again, 6 and 8, let's look at these two numbers. If we're looking at those, again, it's not their factors this time, but it's going to be their multiples. So if you're going to write down the multiples of 6, you would go ahead and write 12, then 18. What's the next one, everybody? Shout it out.
24. 24.
That's right, 24, and then 30, 36, and onward. Then if we do if we do 8, we see that we're going to have 16. What's the next number, everybody?
24.
24. One more after that one.
32.
32. And then you can keep going forever and ever and ever and ever and ever, right? And so what if we did continue going on? Because I got to make this point. I got to make sure you understand what's going on here. After 36 for 6, what's the next number after 36 for 6?
42.
Correct. One more. What's the next one?
48.
48.
Correct. Booyah. All right, let's go ahead and go back to that 8 real quick. What's the next one after 32 for 8?
40.
Correct. And what's the next one after that?
48.
Correct.
48.
All right, so let me go ahead and make this point for y'all. Again, it's in the name. It is in the name. Least common multiple. It is the smallest multiple that they have in common. All right. And so with that said, boom, you're going to look at right here. You're going to see that you're going to have a 24 and a 24 right there. So they have that in common. But you could also make the argument like, hey, there's a 48 right here and a 48 right there. But again, which one are you going to go with, everybody?
The least.
The least, the smallest one, exactly. And in this case, that would be the 24. That would be the 24. So again, guys, look, this one isn't too terrible of a topic. I'm going to show you different techniques in terms of how to calculate that GCF and LCM. That way you can make it a lot smoother once you get into those problems. And then we're also going to be looking at word problems to really dissect those keywords to be quick at this. Because at the end of the day, you get time to the ASVAB. So, we need to work on those strategies. But first, we need to take a second to understand the concept completely. So again, the 24 is what we would go with because it is the least common multiple. LCM equals 24 here. Here, the GCF was 6. All right. Oh yeah. So with that said, hey, welcome, Brittany. Oh, and congrats again on signing up, Brittany. I saw you signed up earlier. So welcome to class. But yeah, so there we are. So take a quick screenshot of this if you don't feel like you have enough time to write this down. If you just kind of came in, don't worry, but go ahead and screenshot this really quick. I'm going to ramble for the next 5 seconds to give you that chance. Because what we're going to do next is we're going to be looking at just a couple of warm-up problems. I'm going to show you how to use what's called a factor tree to get this done. So everybody, real quick, yes or no? Have you ever heard of a factor tree before? Have you ever heard of that before?
Yes.
Yeah.
All right. I like that a lot of us have.
No.
Oh, no, not really.
No,
Yes.
I haven't.
You haven't? All right, that's fine. No worries, because we're going to be going over it, and we're going to go over plenty of examples. I got you. We have at least 4 examples to go through before we start looking at word problems. So I really want to get to those first, because then obviously we can make the word problems a little easier. All right, hey, Alexis, no worries if you don't remember. It's all good. All right, so here's the thing, guys. When it comes to greatest common factor and least common multiple, like these are problems that if you know your mental math, you're going to be just knocking this out of the park. But even if we don't have mental math, we all got to start somewhere, right? So let me show you how you can use a factor tree to get this done. So again, this is what we're about to do. We're about to create what's called a factor tree. Let me use a different color here. Let me use blue. All right. So we're going to be using the factor tree method. All right, that's what we're using. The factor tree method. All right. So let's go ahead and begin here. Let me just zoom in a little bit. So again, that says factor tree method, but we're going to focus our attention here on that 15 and that 40. So watch how this works. Let me just make your lives a lot easier, everybody. Let me grab the 15 over here in red, and let me grab that 40 over here in purple, right there. So with that, let's go ahead and start with the 15. Everybody, what's the number that goes into 15?
5 and 3.
5.
Right, and I like you said 5 times 3, right? 5 and 3 as in 3 times 5, for sure. Go ahead and write that down. Kenia, is that you?
Mm-hmm.
That's cute. All right, hold on 1 second, guys. I need to go ahead and reconnect my Apple Pencil real quick. All right, thank you. All right, so we can have 3 times 5. And everybody, can we break the 3 or the 5 down anymore, or is that as far as we can go?
That's as far.
That's how far we can go.
Exactly. That's as far as you can go. We can't break it down any further because everybody, what's that word again? 3 and 5 are both blank numbers. What is that in there?
Prime number.
Prime number.
Prime.
That's right.
Prime.
They are prime numbers. So that's the technique with the factor tree method. You want to break it down until you get only prime numbers because you can't break it down from there. All right. One more time. You want to break it down to the prime numbers because you can't break it down any further from there. So that's the technique here. Break it down. Into break it down to prime numbers, then compare from there. All right, so there we are with the 15, like we're done. 3 and 5, that's it. Now for the 40, everybody, let's go ahead and focus on that for a moment. So I'm going to zoom in a little bit. If you didn't see that right there on the side, it says break it down into the prime numbers and then compare from there. So let's go ahead and go to the 40 here. So with the 40, what are 2 numbers? It can be any 2 numbers. What 2 numbers multiply
5 and 8.
One more time.
10 and 4.
5
and 8.
2 and 20.
Not 5 and 20. I think I heard 5 and 8. That would be correct.
Yes, sir.
5 times 8 would be correct. And we're not quite done yet here because we can continue breaking 8 down, right? Exactly. We can keep breaking that 8 down. We can absolutely keep breaking that 8 down. And so I got to ask, if we have background noise going on, I'm just going to ask that we keep our mic muted and use that chat box just to keep things fair for everybody. Please and thank you. But no worries. So the 8 here, let's break that down. 8 is what times what?
4 times 2.
40. Oh, wait.
4 times 2. And then the 4 can break down into 2 times 2.
2 times 2.
All right. So what you can say here is that what 2 numbers? So if you look at the factors that we have 3 and 5 there. We got 5. And you're going to look at the lowest part of this. So 2, 2, and 2. We're not going to be looking at these because the 4 is 2 times 2. That 8 is that 4 times 2. So you don't want to grab those numbers. You only want to grab the ends. All right. You only want to grab the roots, the end of the roots of the tree here, of that factor tree. And so taking a look at the 15 and the 40, what factors do we see that they have in common, everybody?
5.
Right.
5.
We absolutely see that they have these 5s in common. So I'm going to go ahead and grab these gray right here. Booyah. Yeah, we absolutely have that 5 in common. Is there anything else that they have in common?
No.
No.
Nope. And so that's it. The GCF of 15 and 40. So the greatest factor that they have in common is going to be 5.
5.
Done.
You're
What's up, Simone?
what's up?
Yeah, but that's it right there. You're just going to find, again, all of those factors of both numbers, and then you're going to pick out all the ones they have in common, bring them together, and we're good. But notice that in this example, there was only one number that they had in common, right? Now we're going to be looking at an example where maybe they have more in common. So let's go ahead and take a look here at the 28 and that 42. I'm going to keep this zoomed out for a moment, and then I'm going to zoom in after everybody's done writing down that last example.
Hey,
let's
Anderson?
go ahead and do it again to show you.
Yeah, I had a quick question, Mr. Anderson.
Yeah, what's up, Vaishon?
For that 40, what if you broke it down like with 2 and 20?
Yeah, you can also do 2 and 20, and you'll get to the same thing here too.
Okay.
Let me actually show you real quick. So that's a good question, man. So I'm going to break it down again into, 40. You can do 2 times 20.
Yeah.
But that 20 is going to break down. You can say 2 times 10. And that 10 can be 2 times 5, right?
Yeah.
Cool. So watch this. We have 1, 2, 3 2s. So 2, 2, 2, and 5. 2, 2, 2, and 5. Same
Okay.
deal. Breaks down the same way. So you can actually go whichever way you want, whichever way you're most comfortable. Just keep breaking it down from there, and you're all good.
Hey, Anderson?
Hey, what's up, Jacqueline?
Hey, just a quick question. I know we're about to do that other problem, so that might answer it. But just to be clear, if there's 2 numbers that have more than one factor, as in like this last problem only had that 5 in common, so that was an easy answer. But if they have more than one number in common, the greatest common factor would be the largest number?
No, you're actually going to bring them together. So I'm going to show you exactly how that works in a moment. So that's a good question. I'm glad you're curious about it because we're actually going to go into that right now. Yeah.
Okay.
Yeah, I got you. So let's go ahead and move it over here for the 28 and 42. So let me just grab this and just make it a little smaller, move it out the way for a moment. All right. So I'm going to use, orange for the 28, and I'm going to go ahead and use, let's go ahead and grab blue for 42. All right. So here we go. So 28, everybody, give me just 2 numbers that will multiply to 28.
4
Nine.
and 7.
7 and
4 and 7. Cool. Sounds good. So 4 times 7. Can we break down the 7 anymore?
No.
No.
No, because it's prime, right? So you'll stop right there. Cool. So you'll stop right there with the 7. Next, 4. That's just going to be what times what?
2 and 2.
2 times
2
2.
times 2.
Times 2.
2 and 2.
That's right. That's right. So there we go. And we're done there because 2 are prime numbers. So boom, that's it. So we got 2, 2, and 7. So let me go ahead and just write that out, what it's going to look like. 2 times 2 times 7. That's the same thing as 28. All right. That's all we're saying. Like 2 times 2 times 7 will give you 28. Now let's go ahead and look at the 42, everybody. Let's break this down again. Nice and easy for ourselves.
7
Everybody,
and
what are
6.
2 numbers that multiply to 42?
7 and
6.
Right, 6 and 7. So let's go and do it that way there. 6 times 7. That's one way a lot of us know it. We can also do 2 times 21. And then you can also do 3 times 14. Like those are 3 different ways you can do it. Now let's go ahead and break it down here. So that's 7. That's done. That's a prime number. Can't break it down, right? But that's 6. What is that going to turn into?
2 times 3.
2 times 3.
That is correct. 2 times 3. So that 6 breaks down a little more here into 2 times 3. And those are both prime. And so we're all done. So what you have for 42 is going to be 2 times 3 times 7. And that's it right there for 42. Now, let me show you how this is all going to work out, everybody. What you're going to do once you have both of these factor trees, all you got to do is highlight the ones they have in common. So everybody, I'm going to go ahead and highlight this 2 right here. Is there another 2 that matches up with it? Yes, right over here. Notice I can't say both of these 2s. You're only going to match up the number of ones that you have in common. So if I only have 1, 2 here, or if I have 2 2s, and I got 1, 2 over here, then you only have 1 pair of 2s right there and right there. Does that make sense, everybody? You can't just say both of these 2s work. You can't. Only one of the 2.
Can I ask a question?
All right. Hey, what's up, Bendigo?
Okay, so how was taught when you do like the factor trees? I don't know if I'm confusing myself because like I remember when we did the factor tree, the teacher was like, if you had like 2 of the same numbers that you could square them, but it didn't sound right to me. So I don't.
Your teacher, all your teacher's saying is if you have 2 times 2, you could write 2 squared times 7, because the exponent just means that you got 2 of that number, and you do. That's all she was saying. I'm not going to break it down that way. For the purpose of this, we don't have to break it down that way, and I'm not going to.
Good, because I was confused. Thank
You're
you.
good. You're good. There will be a lesson where we do that, because exponents are important for the ASVAB. But for right now, we're focusing specifically on LCM and GCF. So to make things easy for everybody, we're just going to keep it light. I got you. That's a good question, though. I got you. So here we are, though. We have a 2 over here, a pair of 2s that we're good at. What's the other number that matches up on both?
7.
7.
Exactly. That 7 matches up. We have a 7 here and a 7 here. So what does that mean for us, everybody? What does that mean? Well, what that means is that you're going to have a 2 and a 7 that they both have in common. And what we're going to do is multiply them together. Because notice how this factor tree is all multiplication, right? All multiplication. So you're going to take those 2 factors that they have in common, multiply them together. Everybody, 2 times 7 is
14.
14.
And that is your least common multiple. Right there. Your least common multiple is going to be 14. Because what you're going to notice is that 14 goes into 28 2 times, 14 times 2. 14 goes into 42 3 times, 14 times 3. That is going to be, why did I say LCM? Jesus. GCF. I was looking at that like, that looks funny. But GCF, that is why the GCF, the greatest common factor, is going to be 14. Because the 2 and the 7 is in common for both. Bring them together and you're done. Give me a yes or no if that makes a little bit of sense moving forward. That way we can kind of feed forward into that. How's that feel?
Yes.
Yes.
Perfect. And Jacqueline, did I answer your question there? So again, now that we have a 2 and a 7 there, boom, you just multiply those together again and you're good. Cool. Sounds good. So again, guys, look, again, it's all about what is the greatest number that they have in common. And if you're using a factor tree to do that, you're going to grab everything that they have in common and multiply it together. Boom. So you see that there's a 2 in each and a 7 in each. So 2 times 7, 14, and you're done. You are not doing 2 times 2 times 7 times 7. No, you're not doing that. You're seeing what they have in common within. And they each have a 2 and a 7 in common within. So you multiply that 2 and 7 together and you get 14. So there's that. Now, again, that was greatest common factor. Now I'm going to go over least common multiple here. So let's go ahead and go over that in a quick moment here. So first and foremost, the thing is you're still going to be using a factor tree. All right. You're still going to be using a factor tree. But here's what's going to be different. And I'm going to go ahead and go back and forth between this page and the previous page to really show you, again, what those differences are going to be. But here, we're still using a factor tree. All right, we're still going to be using that factor tree method. But here's the idea now. The idea now is that what we're going to do is once we're done with the factor tree, once we're done factorizing everything, we are simply going to do the same thing. Highlight what they have in common, but then bring in what is not in common, okay? So again, you're going to do the factor tree. So complete the factor tree. Let me not say do the factor tree. Complete the factor tree. All right, complete that factor tree. And then number 2, what you're going to do is then grab what they don't have in common and bring them in. So bring in what is not in common. I'm going to show you exactly what that looks like. So bring in what is not in common. All right, and I did that in red on purpose because I'm going to use red to do this here. All right, so with that said, hey, Justin, appreciate that, but you got to keep the conversation here to what's going on, man, because this is distracting. All right, so with that, here we go. Let's go ahead and start here with the 15 and the 12. So here we go. Let me grab blue over here for that 15. And then 12 right here in purple. All right, so here we go, guys. 15, everybody. Let's go ahead and go again. 15, what are the factors of 15?
3
and
and
5.
3 and 5.
3
Right,
and
we just
5.
did that. We literally just did that. That's 3 times 5. We're good. So we got 3, 5. So we're going to do 3 times 5. All right, cool. Now with the 12, let's go ahead and go there. What are the two factors that we can start with there?
4 and 3.
Right. A lot of us like 3 and 4. A lot of us like that. Are we done though?
Nope.
Nope. 4 can be broken down into
2.
2 and 2.
right, 2 and 2. So notice that this beginning process is the same for both. This beginning process is the same for both. And it absolutely is. But let me just remind us again, when we did factors, let me go ahead and back up really quick. When we did factors, we said, hey, let's just highlight what they have in common, and that'll be it. Same thing over here with the 28 and 42. We said we got a 2 and a 7 in common. Cool, we'll multiply that together, and we get that 14, and we're done, right? Here's how LCM is a little different. All right, here's how LCM is just a little different. What I'm going to do, I'm going to do the same thing. Starting off, everybody, 3 and 5, 2 and 2 and 3. What do they have in common here?
3.
3.
Right, they just have the 3 in common. They just have the 3 in common. That's right, right there. And so the question now is, what don't they have in common? So with that said, look at what we highlighted. We highlighted that 3 there. Now, if we take a look, and let's just go ahead and start with the 15 side, because here's the thing. You can do this with either number. It doesn't matter. It always works. So watch this, everybody. I'm going to blow your mind. Everybody, look, we highlighted the 3 here, but we didn't highlight these 2s over here. So what I'm going to do is put them right there. Times 2 times 2. Because watch this, everybody. Watch this. Everybody, 3 times 5 is obviously going to be 15. Yes or no?
Yes.
Yes.
Yeah.
Right, that's 15. Now, everybody, let's go ahead and multiply it by 2 again. Everybody, 15 times 2 times 2. What's that going to give us?
60 again?
60.
That is correct. That will give us 60. And I'm breaking it down all the way through for us. That's going to be 60. And that's going to be the least common multiple. For least common multiple, again, what you're doing is grabbing what they don't have in common and putting it in with the other number. Now, if you're going to ask me, does it matter which number? Can I go ahead and start with the 12 and do that? You absolutely can. Yes, you can. Yes, you can. Because watch this. Let's go ahead and say, I'm going to repeat this. And let's go ahead and say I repeat this entire thing. Let's go ahead and say I repeat the entirety of that. Watch this, man. This is actually pretty cool. Because what I'm going to do is I'm going to erase all this over here, erase all of that. I'm going to pretend that I didn't do any of this. Watch this. This is actually pretty cool. Because everybody, we saw that when it came to the 15, we only highlighted the 3. And so we're going to take the rest and put it with the other number. That 2 times 2, I'm going to put it in there because that's what's missing. And we got the 60. Watch this over here. Same thing. I replicated the situation. Instead of starting with 15, I'm going to start with 12. So I got a 2 times 2 times 3. They got the 3 in common. Everybody, what number is the one that the 12 doesn't have?
The 5.
5.
That's right. The 12 doesn't have that 5. That 5 is not in there. It is not in there. So what we're going to do is we're going to grab that 5 and throw it in here. We're going to actually just literally take the 5 and throw it in there. Because everybody, I think we can all see here that already 2 times 2 times 3, that was the 12, right? 2, 2, 3. This right here is the 12, right? Is everybody okay with me just writing 12 over here?
Yeah.
All right, cool. I hope we're good with that. Because all we're doing is taking the 12 and multiplying it by 5. Everybody, what's 5 times 12?
60.
Hey, we taking a little long on that. How we doing on mental math, guys? Yeah, 5 times 12 is going to be 60 there. Good job. Good job. And so it's going to equal 60. And so again, that LCM. Do you guys notice that you can go either way, and still get that LCM?
You just blew my mind. Hold on, you just blew my mind.
Hold on, where did the 12 come from?
Okay.
He just blew my mind. Hold on.
I got y'all. So with that said, let me go ahead and answer Vaishon's question. So Vaishon, you were asking where the 12 came from?
Yeah.
All right, I got you. So it's gonna be right over here. So the 2 times 2 times 3, I'm just helping you see a little faster way to do this, because when you take a look here, 2 times 2 times 3, that is exactly what made up the 12.
Okay.
2 times 2 is 4. 4 times 3 is 12, right? So all I did was just notice that I don't have to do the same word twice. I literally just broke this thing down to 2, 2, and 3. So you could just rewrite it as the number that it was. That's all I'm saying.
Oh.
Yeah, just making your life a little easier before you plug that number that's outside back in.
You literally just blew my mind, Mr.
But that's all I'm trying to show you. I'm just trying to show you that you can go either way with this. Again, for least common multiple and greatest common factor, first start off with making that factor tree, okay? The factor tree is how you start off. From there, for greatest common factor, you highlight what they have in common, and that's it. You're going to multiply whatever they have in common together, and boom, you're done. For least common multiple, you highlight what they have in common, and then include what is not in common. You're going to bring in what's not in common, and that's going to give you the least common multiple. That is the sincere, clear difference between the two. All right. So on a scale of 1 to 10, how much sense does that make so far? Because we're going to do one more example here, and then we're moving forward with the board problems examples.
I'll give it like an 8.5 because you just blew my mind.
Hey, it's all good, man. That's what we're here to do. We're here to learn.
As soon as you start with 1 to the 5, I was like, hold on, you just blew my mind like right there.
Yeah, you are perfectly allowed to do that. Let me see these responses here. So we have a lot of 10s, 9s, 8s, 7s, 10s, 9s. All right, looks like we're doing okay. Yeah, for sure. More practice is always perfect, right? More practice makes us perfect. And so that's what we're going to be going for next. But that was that. So now let's go ahead and look at this next example, the 24 and the 18. So again, remember, guys, for least common multiple and greatest common factor, make your factor tree, highlight what they got in common. But for least common multiple, you're going to bring in what they don't have in common. That's how you're going to do it. So watch this. Here we go. I'm going to do blue over here for 24. And then I'm going to do, let's go ahead and say pink for 18. So here we go. In the blue for 24, somebody give me 2 numbers real quick that go into 24.
6 times 4.
6 and 4.
6 and 4. I heard that. That was pretty popular. Good. So 4 and 6. I usually go in order there. And also to answer your question, Julian, good question. So Julian asks, define prime number when you get a chance. So a prime number is a number that its only factors are 1 and that number. So an example of a prime number would be 2. 2 is only made up of 1 times 2. Or 3, 1 times 3. Or 5, only 1 and 5. An example of a not prime number would be 4, because 4, you have 1 and 4, but you also got 2 times 2. Another example of a not prime number would be 6, because you got 1 and 6, but you also have 2 and 3. So for a prime number to be prime, you can only have the factors of 1 and that number. Does that help out a little bit, Julian? Let me know. I saw you on the mic before.
Yeah, thank you.
Cool. Sounds good, boss. All right. So with that, let's keep it going here. So the 4 and the 6, we're not done here because the 4 can break down into what times what, everybody?
2 times 2.
2.
2 times 2.
That's right. And that 6, what can that break down into?
2 times
3.
That's right. 2 times 3.
3 times
And
2.
so what we can do with the 24 is we can literally write down 2 times 2 times 2 times 3. That is what we have right now for the 24. Let me see if I can just make a little box real quick. Cool. And that just showed me I write crooked as hell. All right. So 18. So if we're looking at the 18 here, let's go ahead and start off with the 2 easy numbers that we can break down.
2 and 9.
3 and 6.
2 and 9 or 3 and 6. Exactly. They both work. So I'll just do 2 and 9. And then everybody, what's 9 broken down into?
3 times 3.
3 times 3.
Yeah, 3 times
3.
3. So again, notice that we're breaking it down all the way to those prime numbers, to those prime factors. The reason you do that is because it makes it so much easier to spot those common factors. So we got 2 times 2, or excuse me, 2 times 3 times 3. So I'm going to write that down right here as 2 times 3 times 3. And we'll box that off as well. That was a lot better. All right, cool. So with that, here's what we're going to do again. Same deal. You're going to highlight what they have in common. Notice how we have literally 3 2s here. You are not grabbing all 3 of those 2s. You're only going to grab one of them for each other one that you have. It is not like I got 1 here and 3 there. I got 3 in common. No, bro. You got 1 here, 3 there. You only have 1 of them in common. If you had 2 here and 3 there, then you have 2 of them in common. Does that make sense, everybody?
Yeah.
Yeah, I really got to make sure we're not getting overzealous here, being like, oh, I got 3 2s and I got 1 2 here. Oh, I'm going to highlight all 3 of them. No, that is not what you're supposed to do. It is 1 for 1. It is 1 for 1. All right, cool. Perfect. So that's the idea there. It is 1 for 1. And now what we're going to do is, did we forget anything, guys? Is there any other number here?
3.
The 2.
3.
3, exactly, the 3. So we got to grab that 3 there as well. So here's the 3 and one of the 3s there. So boom. All right, now that we got those things that are in common, which way do you think is easier, guys? Do you think it's going to be easier to grab, a 2 and a 2 and put it in there, or just to simply grab a 3 and put it over here? Which way do you guys think?
The 3.
Grab the 3.
The 3.
Yeah, let's just go ahead and grab that 3 and put it over. Exactly. So we can just go ahead and say, hey, look, we have that, but not this. Let's just take that and put it right there. And so basically, everybody, just to remind you, shortcut method. What the heck is 2 times 2 times 2 times 3? What did we say that was going to be?
24.
24.
Exactly, because we just did it right here.
Yep.
We just did it. Remember, this is 24. This is 24. We literally just did it. We literally just did it. And so you don't have to do all that work again and go 2, 2, 4, 8. No, you don't have to. It's 24. Then you multiply by 3. And everybody, what's 24 times 3?
72.
72.
Ooh, someone got that mental math going on. That's right. Because again, if you're doing 24 times 3, you can use that split and glue technique that I teach. 20 times 3, 4 times 3. Bring it back together. 60, 12, 72. And again, you can do it the other way though. If you wanted to take these 2s over here, if I really, really wanted to take these 2s over here and put them over here to multiply by 4, that's just going to be 18. And let me not confuse anybody. And because I don't want to make too much of a mess here. I'm going to show you how I can still get there the same exact way. Because notice how we're missing that 2 and 2 from the 18. So let me show y'all real quick. Everybody, what's 18 times 4? Let's try that out. 8 times 4, that's going to be 32. 1 times 4 is 4. 4 plus 3 is 7. 32. Oh my God, it works either way. So Drea, hey, good question there, or not a good question, but good statement there. So thanks for letting me know that confuses you a little bit. So Drea's saying, hey, look, this is where you get lost, knowing how many common factors to move. So Drea, the thing is, for least common multiple, you're not moving any factors at all. You're only moving what is not the common factor. That's the idea there. So notice how I looked at this and I said, hey, look, I got my 2, my 3 in common. So I ain't going to touch those. It's that 3 that I'm going to take and put it over here. Because at the end of the day, this big block right here was 24. Let me just erase this so you can see it better. This big block here was 24, like we just broke it down. And so we're just taking that 3 and put it in. We're only grabbing, again, what is absolutely necessary. We're not grabbing any extra. We're not grabbing an extra 2. We're not grabbing an extra 3. We're only grabbing what is absolutely necessary. And that's only going to be that 3 that wasn't highlighted. So we take that 3, put it with the other number, and that's it. That's all she wrote. You can do it either way. I can go and say, take these 2 2s and put them over here. Yep, you can do that. You'll still get 72. Either way. So are we feeling a little better about that, Drea, or would you like to see more practice with that? Because obviously you probably would like to see more practice, but does that make a little more sense for you? Because again,
all right, quick question.
I got you 1 second, Vaishon. Just want to see what Drea's in practice is going to help for sure. Cool. Sounds good. Vaishon, what's up, boss?
I just wanted to know where did the 4 come from?
The 4, where here? Where are we looking? Oh, the 18 times 4? Yeah. So I'll show you the other way around now. So to show you the other way around, I said, hey, look, let me go ahead and pretend that I didn't go this way, right? Let me pretend that I didn't do this. Let me actually go the other way. Let me go ahead and pretend that if I take these two 2's over here and put them over here, I'm going to do all that 2 times 2 times all that. But what's 2 times 2 again?
4.
4.
That's why.
Okay.
Yep. That's it right there. And that's it right there. Hey, no worries, Yesenia. So at the end of this, I do have a lesson on this that you do want to watch. On Thursday, we're going to be going over even more problems moving forward from here. So no worries. Do what you can here. And then on Thursday, we're going to be kicking it up. So with that, guys, we're going to do some word problems here. We're going to do some word problems. Now, I want to show you, I'm hoping I can show you at least one example for LCM and one example for GCF. And I want to show you some test level problems, like a problem that you could legit see on the test, but I'm going to show you how to break it down so that it doesn't really trigger all of that anxiety, that blanking out. I don't want that to happen for y'all. Has that ever happened to anybody here? Yes or no? Have you ever blanked out on a problem that
Yeah.
Oh yeah.
like maybe you could do for some reason? You're just sitting here like, what the?
Multiple times.
Right? We don't want that to happen. So we're going to make sure that doesn't happen here. We got this. So pay attention to the wording and the keywords. Got to pay attention to those. So if you're asked to find like the max or the most, anything that indicates greatest or the most amount, yeah, that's going to be the greatest common factor. When you have, can you find the minimum or the smallest or the least that these two numbers intersect at? That is the least common multiple. So I'm going to show you the clear difference between both of these. So here we go. Take a screenshot of this if you need to. Take a screenshot of this if you need to, because I'm going to go over both of these questions. Hopefully we can go over one more after that. But if not, don't worry. We got Thursday to get 2 straight hours of practicing. All right, so here we go. Let's take a look at number 1. Take a screenshot again if you are running out of time writing. That way you can get all that down. 2, 1. Julian, hopefully you got that down, boss. Let's try to wait for you there. Cool. All right, so here we go. Let's go over this first guided question. So first and foremost, everybody, what do I always say when it comes to word problems?
Read the question first.
Read the question.
Read the question first.
I love how that chat box blew up, man. Yeah, read the dang question first, man. Look, I say this to everybody, and I'm gonna sound like a broken record, but I'm saying it primarily for everybody and my new folks. You always want to start by reading the question, because there's nothing worse than playing a game that you don't know the rules for. Reading the question tells you the rules of the game. It tells you what the objective is. So right here, starting off, what is the greatest number of bags she can make? You always want to start with the question. And everybody, in that question, what word do we see that really gives it away in terms of LCM and GCF?
Greatest.
Absolutely. Absolutely. Right there. Greatest number of bags that she can make. But right there, it is greatest number of bags that she can make. So does greatest tie into GCF or LCM?
GCF.
Yeah.
That's correct. That's correct. That's correct. Hey, Ryan, you may need to swipe if you're using an iPad or a phone. You might want to swipe. If you swipe around, you should be able to get to the shared screen there. But yeah, we're doing GCF here. That's what's going to happen here. And so let me go ahead and write that down. Greatest common factor. It's very likely that that's going to be the case here, because let's read the question. Let's read the problem here. And I'm going to highlight some important information. So Miss Skinner was working with the volunteer club to make bags of treats for a nursing home visit. Ain't that sweet? Now, she bought a bag of 18 chocolates and a bag of 12 pens. Each bag of treats will be identical. What is the greatest number of bags that she can make? So you see here that she bought a bag of 18 chocolates and a bag of 12 pens. I don't know who's trying to mix chocolates and pens together, but whatever. So 18 chocolates, 12 pens, and we want to know what the greatest number of bags that we can make is. So let me show y'all what we can do here. We got 18 chocolates. Let me use brown for that because obviously chocolate. Go ahead and use that. 12 pens. All right, so 18 chocolates here. And then we got 12 pens. Pens, I'll just go ahead and use purple, I guess. So everybody, look, this is what we mean. This is what we mean. Like, I want to really help you guys visualize what's actually going on. Because there's nothing worse than a teacher that kind of just says, oh, you see this, do that, have a good day. Like, it doesn't really help you out. It doesn't really train you to understand what's going to happen for the next problem. So let me just show you what's happening here. They're asking, hey, if we have 18 chocolates and 12 pens, and read this key piece of information right here. Every bag is identical. Every bag is identical. So what we're saying is that, yo, if you're going to put, you know, one chocolate and one pen in one bag, you know, if you're going to do that, then that means that all of the bags have to be one chocolate and one pen. And so what you can do here is you can use greatest common factor to actually get this done without having to do all the guesswork. Because literally you could be like, all right, let me go ahead and put, you know, 2 chocolates and 1 pen in the bag there. You know, let me tie it up, whatever. And if I keep doing that, if I keep doing 2 chocolates, 1 pen, 2 chocolates, 1 pen, if I keep doing that and keep doing that, will I get to 18 chocolates and 12 pens? Like, will I use up all of my stuff so that way everything is even? So basically, again, we're trying to figure out how many bags, what is the most number of bags that we can make with these same items in them. Is that starting to make a little bit of sense here in terms of visualizing? Because what we're going to do now is use the greatest common factor to show it.
Yes.
I'm expecting some no's here. So if you're saying no right now, hey, be honest. Again, it is okay to be honest here. I'm not a god, all right? So I want you guys to be honest and saying, hey, do I get it or not? Be all honest with me. So I see a few, you know, quite a few yeses here, some no's. No worries. Watch this, guys. Watch this. Let's go ahead and make our factor tree here. So for 18, everybody, what's that going to be?
3 and 6.
3 and 6.
3 and 6. And then everybody, 6 breaks down into what and what?
2 and 3.
3 and 2.
Cool. So is it safe to say that we got 1, 2, so 2, and then 3, 3, so 2 times 3 times 3, right?
Yes.
Yes.
Cool. Sounds good. All right, let's go ahead and go to 12 here then. Let's break 12 down. So 12 breaks down into what and what?
2
3
and
and
6.
4. 6.
All right, I'll do 2 and 6 because I did 3 and 4 last time. So I'll do 2 and 6 here. And then 6 breaks down into what and what?
2
3
and 3.
times 2.
Right,
3
2
and
times
2.
3 again. Exactly. And so with that, watch this. 2, 2, and 3. 2 times 2 times 3. So remember that we said that we're looking for the greatest number of bags that she can make. And so with that said, all right, we got 2 times 2 times 3 here, or 2 times 3 times 3, 2 times 2 times 3 here. Let's grab those things that they have in common. Do I have a 2 over here and over there?
Yes.
Yep.
Yes.
Yes.
Yes, we do. Do we have a 3 here and another 3 to accompany it?
Yes.
Yes.
Yeah.
Yes.
Is there anything else?
Yes.
Nope.
No, that's it.
No.
That is
No.
it. Because you have an extra 3 here, but only a 2 there. So notice how they don't have anything else in common. Do we see that right there? That we don't have anything else in common?
Yes.
All right, cool.
Can I ask a question?
Yeah, absolutely. What's up?
So, would you bring this 2 over to that 3?
No, because that would be least common multiple. So here we're only using greatest common factor.
Okay.
And so from over here, in this example here for greatest common factor, again, we only highlight what they have in common and we bring that together.
Okay, thank you.
And that's it. And that's it for greatest common factor. That's all we got to do. Because if we have 2 times 3, everybody, what's 2 times 3?
6.
6.
6. Same thing over here, 2 times 3, 6.
6.
And so the answer is going to be, I'm going to write this in red here. 6. How many? 6 what? What is the thing we're talking about?
Bags.
That's right. 6 bags is the most that they can make. 6 bags is the most that they can make. Six bags is the most that they can make. Because watch this. Look, this is how it works. I'm going to use red here again. 6 bags. If I got 18 chocolates, that means 3 chocolates in every bag, right? Right there. Because again, 6 times 3 is 18. So we got 6 bags with 3 chocolates each. And let me actually go ahead and let me just use a red box for this actually. Because I'm going to use brown for that. Change that to brown. So that way you can really visualize. I really want you guys to visualize this. All right. And so for the pens, everybody, if we are using 6 bags and we got 12 pens, how many pens are going to be in each bag?
2.
2.
That's right. There's going to be 2 pens in each bag here. So we got 2 pens, 2 pens, 2 pens. That's 6, 8, 10, and 12. So let me go ahead and just circle these together here. So I got 1 bag right here, 3 chocolates, 2 pens. Another bag, 3 chocolates, 2 pens. Another one, 5, and 6 bags that are identical. You see how every bag is identical?
Yes.
That's what we're talking about here. Like, that's the visualization I want you guys to see with a problem like this. Is this making a little more sense for anybody?
Yes.
Yes.
Yes, it does now.
Yeah, because I know with something like this, like it's hard to visualize. It's like, how do you visualize greatest common factor? Trust me, I was there. I was in class one day and I was like, what the hell? But the thing is, like, this is how we can use it in this instance. You can basically, instead of going ahead and literally trying out a bunch of different combinations, like, oh, 2 chocolates, 1 pen, or try this and that. Instead of doing all that hoo-ha, you can use this factor tree, break it down, and you're good. Now, Jennifer, great question. Is there a faster way to do this? Fact of the matter is, yes. With more practice, you won't have to be breaking down 18 and 12. You can honestly be like, all right, 18 is 6 times 3, 12 is 6 times 2. 6 is the greatest common factor. Done. Seriously. But it takes practice. You can't just expect to get there on day 1, but you can get there eventually. And that's why I said mental math is king here. But again, we got to start somewhere. We got to make sure it makes sense some way, somehow. So let me know if I answered your question there, Ro. Hey, you're good, Carmen. You're good. Alexis, 18 minus 12 is just a convenient way to do it here. It's lucky. Like, not always, it's not always the case that the difference is going to be the greatest common factor. It's not always the case. Not always the case.
The only reason why I say 18 minus 12 is because the bags say it's identical. So that's why I just subtracted the 18 from the 12.
Oh, to do like 12 chocolates and 12. Not exactly. No. You're good though. That's I can see where you're going with that. But not exactly though. So Drea, so you can say in GCF, the matches cancel each other out. So the thing is, exactly in a way, yeah. So for GCF, you grab what they have in common, and that's all you care about. So you got the 2 and the 3 in common. Boom, bring them back together to make the 6. Yeah. And so with that said, guys, like, it's almost 7 o'clock. You know, that's the time that we were supposed to stop at. But are you guys cool if we do one more so we can do least common multiple?
Yes.
Yeah.
I'm good.
Yeah.
If you guys like that, cool. Because I really want to do least common multiple as well. And then we can feed it forward for Thursday, because on Thursday, we're doing 2 straight hours of practice just for this. So we're doing all of these word problems that you're seeing right here. Every single one of these word problems. All right. So with that, let's go over this next guided question. And then on Thursday, man, we're hitting these home runs. We're going to hit these bombs all day long. So watch this, guys. Here we go. At the store, a package of hot dogs contains 10 hot dogs, and a package of buns contains 8 buns. You want to buy the what?
Least.
You didn't go.
Okay. You want to buy the least number of packages of hot dogs and buns.
You didn't go straight.
So that
to
way
the
there are
question.
no leftover buns or hot dogs. How many packages of buns will you buy? Everybody, let me ask you real quick. You didn't read the question. I know. I want to make sure I can get to, because you guys know, you got to read the packages or how many packages of buns you'll buy. I know. But I want to make sure I get to the heart of the concept right now real quick. So this is a real world situation. Like, has anybody, hopefully everybody here, at least one person here, has gone to a cookout or hosted one, and you're at the store, you're trying to buy all the stuff for it, whether it's hamburgers with the buns or hot dogs with the buns. Has anybody ever been there trying to be like, all right, how many do I need?
I have.
All right, cool. I'm just making sure I'm not crazy, because this is a real world situation. If you got, okay, I get 6 buns in this package, and then the hot dog packages always sell them in groups of 10. I'm sitting here like, why you gotta make me do math? Like, why can't you just sell 10 and 10? But real world don't work that way, right? So with that said, this is a situation where you can use least common multiple or greatest common factor to figure out the best way to save money, essentially. So watch this. So the question first, how many packages of buns will you buy? All right. So the key word here for least common multiple is you want to buy the least number of packages of hot dogs and buns. So notice how we're talking about two things, hot dogs and buns. And then they're saying, I want to buy the least number of both of them so that way I can save the most money here and not have any leftovers. That right there, boom, trigger, least common multiple. Because you're talking about two different things or two different numbers, types of numbers, and you want to know the least that they combine to. That all day is least common multiple. Everybody, yes or no? You got that?
Yes.
It's right there again. The least. Yep. And then hot dogs, and let me use a different color there to make it really clear. Hot dogs and buns. So you see here, you're talking about two different things. Hot dogs has a number for itself. The buns has a number for itself. And you want to know the least of both together. That is least common multiple all day, every day. All day, every day. That is least common multiple of what two numbers?
10 and 8.
10 and 8.
That's right, 10 and 8. 10 hot dogs and 8 buns. So go ahead and write 10 over here. And that was an ugly N. And 8. So here's the thing. Like with least common multiple, here's the thing. Some of y'all know it's about, I'll see you tomorrow on Thursday. But look, here's the thing. You can be adept here and use mental math to really get this done the right way. Because everybody, if you know your mental math, 10 and 8, what number do they both go into? Like, what do they both multiply to?
2.
Not factors. What can they both multiply to get? Like, what can they both go into?
80.
80, because if you do 10 times 8, yeah, they both go into 80. But let me ask you this. Is that the smallest? Is that the least number that they can both go into?
No.
No. Who knows what the number is? Who knows what that number is?
It would be 2.
Not 2, because 2 would be a factor. Here we're doing multiple.
40.
It would be 40. It would be 40. Guys, look, here is the caveman way to do it. You can go 10, then you can go 20, 30, 40, 50. Like you can just literally write out the multiples of 10. You can keep going. You could do the same thing with 8. You can go 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, and you can keep going. And you could be like, oh, in my head, if I just multiply 10 times 8, oh, I got 80. I'm done. What's the problem though? Least. And if you're looking for the least, you might have missed that it's 40. You might have missed that it's 40. And so I don't want y'all to resort to this caveman method. I don't want y'all to resort to that. And eventually, I don't want y'all to resort to factor trees either. But you got to start somewhere. And so I'm showing you this method as a stepping stone. So that way, when you use your mental math, you're sitting here nice, confident, breezy, beautiful cover girl style, like, yo, okay, 10 and 8, I know my mental math, that's 40, we're done. All you have to know is that we're dealing with the least common multiple, right? Because we know how to do our times tables, but do you know when we're applying? That's the biggest question. So without further ado, let's go ahead. Let's break this down real quick for ourselves. And let's see if we can prove that we can get 40 using that factor tree. So let's go here. Everybody, 10, what does that break down into?
5 and 2.
5 and 2.
Right, 2 times 5, and that's pretty much it. We're done. So I'm just going to go ahead and box that up. 2 times 5, we are done. All right, cool. Next, let me go ahead and break that 8 down. Everybody, 8 breaks down into 2 times
4
what?
and 2.
4 and 4.
Yeah, and then 4 breaks down into
2
and 2 times
2
2.
and 2.
All right, cool. So I'm going to say that 8 breaks down into 2 times 2 times 2. Everybody, what do they have in common?
2.
Yeah, how many 2s?
2. I mean 1.
1.
Just one of those 2s,
One.
right? Just 1 2 in common. So I'm going to go ahead and highlight that for ourselves, and I'm going to make sure that we're good here. So we got a 2 right there and a 2 right there. Boom. So let me ask y'all, where do we go from here? For least common multiple, where do we go? What do we say we should do here now?
You multiply.
Bring the 5 over to the 2.
Yeah, you bring the 5 over to the 2.
Exactly. You're going to bring over what is not in common. Bring over what's not in common. Look how easy this can be, everybody. Watch this. Look at how easy this can be. Look, we know for a fact that 2 times 5, that is 10. And we also know for a fact that the 2 times the 2 times the 2, that is going to be 8. We know that. We literally just broke it down for ourselves. We just did this. So we don't have to guess here. But here's where it becomes really easy for us. After you make your factor tree and you do all this hoo-ha and you highlight everything, I'm just going to say, here, look, watch this. I got a 5 right here. I'm going to make this a lot thicker so that it makes that 5. I'm going to put it right there. I'm going to put it right there and just multiply that 5. Everybody, what's 8 times 5?
40.
40.
Done.
40.
And you're done. And that's the thing. Like, that's how you do it. You just break it down in that way. And so if you're saying, hey, what the heck? Why is 40 not an answer? Don't worry. The question is, how many packages of what?
Buns.
Buns. Everybody, how many buns does each package contain?
8.
Okay, cool. So you're saying, hey, look, we got 40 buns. Let me write this over here. And so every package is 8 buns. How many packages is that going to be? If you're trying to,
5.
exactly.
5.
Exactly. Because you're going to do 40 divided by that 8 there is going to give you 5 packages of buns. What does that answer make it?
B.
5.
And that makes the answer 5 packages. Because you got to read the question. You got to read the question. It didn't say what's the least common multiple. That was part of the solution process. But after we got the 40 buns, then we said, all right, cool. That's actually going to turn into 5 packages of buns. And for hot dogs, that'll be 4 packages of hot dogs. Panesa, you had a little light up moment there. Hey. And you know what, guys? Actually, I'll go ahead and put this video up on YouTube tomorrow. That's fine. Yeah. I'll put this recording up on YouTube. That way we can go ahead and keep practicing here and then get ready for Thursday. So I'll go ahead and put this up on YouTube. I got y'all for sure. For sure. Hey, Panesa, I'm just trying to show you guys what's up, man. I'm just trying to show you guys how we can be a little more confident, one day better, one day at a time. So Julacey, I'm not sure how to pronounce it. I mean, if I got that right. But no, so I don't put everything on YouTube. All of the recordings, all 130 recordings right now are all in the group tutoring pass. Every now and then I'll put some up on YouTube. But if you have the group tutoring pass, you don't have to worry about any of that. Everything's already in there, organized for you, and you can watch whenever. And so with that said, everybody, I got to go ahead and just remember, look at the right side here. We got all this practice that we're going to be doing on Thursday. And so with that, before I let y'all go, let me ask y'all real quick, man. You know, we're all done, but what tip or strategy stood out to you the most? Go ahead, type that in, or go ahead and raise your hand in the participant list, and I'll go ahead and call you out one by one. But go ahead. What was that? Like, what tip and strategy stood out most to you? And if you're in the group tutoring pass, again, tomorrow and Thursday, same time, 2 hours this time, though. And if you are not in the group tutoring pass, stick around.